So, like I said, using square root and Pythagorean theorem is the topic for today. The essential question is right there. There's actually two, so get put this topic down. Yeah, so when I collect them, I put them apart from the ones that weren't here, and that way I can check off.
So we don't turn into the videos. We don't turn into the
And I'm watching you guys do these as we go along. So if you're not doing them, if you don't, even if you turn your attendance in, I know you didn't do what you're supposed to do, and I still won't give you credit. So if you're sitting there without taking notes right now, you need to get the notes and you get care of it. Okay. All right. There's somebody has somebody else needs to list too. So done. Here you go. And there's make sure you go. So on the other end, when you get your when you have your stuff all, your special questions all written down, make sure you give me a quick check mark so I know you're ready to go on. Okay. Good with that. Good. And if you're not quite good, you get it from your neighbor. All right, so let's go on. I'm going to do a couple quick review things because we need to make sure we know how to do this before we can do the main thing for today. Simplified radical expressions square root of 40. So now in your notes, remember that left-hand column is where you write a question. So instead of writing simplified the square root of 40 or the word review, what question did you put there? Good. Okay, so the left-hand column, you should be putting a question. How do you simplify? And then you have the steps on the right-hand side of how you're going to do it. Okay, so now you guys are supposed to be doing that. So wait for me to because we talked about how to do this before, so I'm going to see what you remember. It's okay to help each other. Help that by asking questions or things like that instead of just telling them that you want everybody to think it through. Not worth it. I just thought here we could move this over there. Push them together so that some of it, not all of it, is where it keeps you looking for a while. I want to keep it just measure corners. Two. All right. All right. So it looks like a lot of you are kind of going, okay, a lot of you got it down, and went straight to the answer. Some of you are kind of going, I'm not so sure, so I still remember how to do this. So what's the first thing we need to do?
Find the multiple of 40.
Not the multiple of the, there's an F.
Factors?
Factors of 40, good. Yes, I know it's easy to get confused between those, so that's why. So if I splice two numbers and multiply together to make 40.
2 times 20.
Okay, 2 times 20. Somebody else have another one? 10 and 4. So let me write those up there so we can see those. It'll be 2 times 20, 10 times 4. Okay. I'm just going to keep them out from the square root sign for right now. And 10, I'm going to put 4 times 10. Okay. There's probably some others that you come up with. 5 times 8. Okay. So the first step we did was we thought about all the different numbers that multiply together to make 40. What's my question I need to ask myself after I've done that and thought about that? The question I need to ask myself. If I'm talking about square roots, what do I want to be able to do? If it says square root, what am I going to have to do? Take the square root. Take the square root of the number, right? If it says take the square root, that's what I want to be able to do, right? So which one of those three up there is the easiest one? Have something that I can take the square root of easily. 4 and 10. Okay, so I'm going to split the square root of 40. Into the square root of 4 times the square root of 10. And now I can actually take the square root of something, right? So what am I going to get? 2. 2 for the square root of 4 times the square root of 10. And that's all I have to do. Okay, so let's stop for a second and think about what we just did. So let's write about that for just a second, so we can remember. What was the first thing we did?
Find the factors.
Find the factors of the numbers, right? I'm generalizing it so it works for anything. Okay? What specifically were we looking for?
The largest number square.
Okay. So we want to be sure one factor is the largest perfect square of the number. Okay? After that, what are we going to do?
Write the numbers individually.
Okay. Yeah, okay, but there, we can, let's just say, we can write the square root of each factor individually, okay? Once we've done that, what do we do? Then we took the square root, right? Of the factors in the factor. Or it can be square rooted, I'm sorry.
We're not here.
No. Okay? So the first thing we did was we found the factors of the number. Then we wanted to make sure we had found the factors where we had the largest perfect square of the number. Then we wrote the square root of each factor individually. And then we took the square root of the factors that can be square rooted. Okay? So that's kind of a quick review on that. Looks like most of you are just about done writing that down. Okay. And for time's sake, and because it's not that important right now, for this one, let's skip the next review. You guys ready to move on? Okay, I don't want to move on from already. Okay. Just I'm going to have you pull your table up over the so you can be part of the group today. Okay. So let's skip this one. Please, if you did not do this lesson, make sure you go back and do the lesson where it talks about rationalizing square roots. Okay. And also just remember that I told you guys there's going to be extra credit recording, and it's posted. It's been posted since early yesterday. Actually, it was posted not yesterday, the day before. Actually, it's posted on Monday. But it's posted, and it has the directions on how to do this. So everybody here should be pretty much good, unless you weren't, unless you did not turn in the notes for last week. But if you're at week 4 and you have your notes turned in for week 4, then you can do the extra credit notes for week 4 and get more points, make up some points, maybe which you've missed something separate. Okay? So make sure you go take a look at that. And that will also go again over how to review how to do this, as well as what you did within your lesson if you did the lesson. Remember, this does not reflect doing the lesson, you should do your lesson. Okay? So, solve the following equation. I do want to do this one quickly. Refresh our memory on how to do that, because we need to know how to do that today. You've got an answer. Can I check yourself with somebody else at your table and make sure you guys agree? And if there's somebody that's making struggling, you can help them a little bit. That'd be great. Great. So a lot of you guys got stuff is done, and you're doing a great job with it. So let's do this. And so first thing you need to do, remember, we have to ask ourselves is, can I do anything to simplify either side of the equation, or is it as simple as it's going to be, right? And that would be like if you had distributed property or combined like terms, that kind of stuff. And so the left side is the simplified as it's going to go, and the right side is the simplified as it's going to be. Now that it's simplified, we have to ask ourselves, are the x's on just one side of the equal sign? Remember that? And they actually are on one side of the equal sign. Once we've done that, then we have to ask ourselves, are the x's by themselves? And when it says 3x, that means there's x plus x plus x. So I can't separate the 3 from the x. 3 tells me how many x's I have. So the 3x stays together. The 3, we're not trying to get rid of the 3 at this point because we have 3 x's. The part that's extra is the side. Most of you guys do that and did a good job with that. So to get rid of that subtract 5 part, if it says subtract, we have to add. Okay? We're always doing the opposite, right? I'm going to change colors. So if it says subtract, I'm going to add. So I'm adding 5 to both sides. Because that way I get rid of the part that I don't want on that one side of the equal sign. And if it's 3x equals 18. Now I've got 3 x's, and remember my final goal is to find out how much just one of those x's is worth. So if it says 3x, that means 3 times x, right? So if I'm multiplying by 3 to get rid of the 3 to get to 1x, what do I have to do? Divide. And you guys all did a pretty good job of that. We were always doing the opposite of what's showing. So if it said add, you subtracted. If it said subtract, you would add, right? If it said multiply, you would divide, right? If it was divide, you would multiply. All right? Now I'm emphasizing that for a reason. You'll see that in just a second. So you end up with x equals 6. And I walked around, most of you were there. Okay? Make sense? You good with that? All right. So with that said, let's look at this equation. And it says, how would you solve an equation such as 2x squared minus 4 equals 12? So this time it's not just x, it's x squared. So let's stop and talk for a second. You guys said if I see add, I'm going to subtract. If I can subtract, you're going to add. If you see multiply, you're going to divide. If you see divide, you're going to, what if I see squared? Because that means x times x, right? But I only want 1x. So that's a whole lot more than 1x, isn't it, when I say x times x? So if it's a squared, how do I do squaring? How do I deal with the squaring? We did opposites for add and subtract, right? Opposites for multiply, divide. What's the opposite for squaring? What does squaring?
Well, squaring is even times, right?
Multiply by itself.
Will be divided by itself?
That's a thought. What did you say? You said square rooting. Why did you say square rooting? Why? Why is square rooting after squaring?
Because square rooting is something times something.
Yeah, we're trying to find the two numbers that multiply together to make that number. We're squaring to multiply the two numbers to get that number, right? So if we see squaring, to undo squaring, we have to square root. Okay? So try this problem. Do you think there's any different steps beyond what we already know? So try that problem. And the question you would put in your left-hand column is how would you solve an equation such as, right? All right, so most of you, it looks like you've got quite a ways down. Okay, yeah, version, yes. Okay. Okay. All right, most of you got quite a ways down on this and kind of got stuck at the same place. I kind of expected that, so that's okay. At least you know that there isn't anything different to the first part of this than there was to the other problems we were doing with just the x, right? Most everybody got that part. Getting the x's by themselves, right? And then you got 2x squared equals 16. Oh my God. Yay! Celebrate that. Good. Excellent. All right. And then what was the next step you guys did?
I divided by 2.
Yeah, if that was just an x, you would divide by 2, wouldn't you? Mm-hmm. So that's exactly what you do here. No new rules, no nothing. So I end up with x squared equals 8. Now what? Because this is x times x, and I just want 1x, right? Yeah, because it says x squared, so now I'm going to square root it. So I'm just going to put the square root over that, and the square root over that. So I end up with x equals, nope, 4. Okay? All I have to do is write, now that's not simplified, but all you have to do is write it like that. Oh, okay. I have to simplify it still, but now there's only one catch. What two numbers do I multiply together to make 9? 3 times 3? What about negative 3? Negative 3 times negative 3 makes positive 9, right? So, what if I told you negative 4 times negative 4? What do I get?
8. Or 16.
16. Positive 16, right? And 4 times 4 gives me positive 16. So, if I say x squared equals 8, like I had up here before, yes. Okay, this is good. It is going to be a small number. You're right. We're not worried about that yet. What I want to worry about is something else. Do I know what number it is in here to get the 8? Do I know if it's positive or negative? Do we know it? Does this problem tell us anything about whether? Because remember we said to get the 9, you have either a positive 3 times a positive 3 or the negative 3 times a negative 3, right? To get the 9. Do we know from here if we're dealing with the positive number or the negative number? We don't, do we? There's no way to tell.
Doesn't it not matter?
Does matter. Yeah, it does matter. So when I write my answer, I get a positive square root of 8 and a negative square root of 8. So I have two answers. I wrote it as, so it looks like it's 1, but because I have a positive square root of 8 and a negative square root of 8, I get two answers to this problem. And why did I get two answers to this problem? Because we don't know whether the number here is negative or positive. Right. Okay? Did you guys just get the answer to your essential question? No.
Yeah.
Yeah. Okay. All right. So, really important. Now,
What does that mean?
That's the,
I've seen that before.
the positive over minus.
Minus and then
That's exactly what that means. It means you have two answers. One's a positive of that, and one's a negative of that. You can write them separately. You can say square root of 8 and negative square root of 8. If that's more comfortable for you, but if you want to simplify it, you can do that. And then we simplify that. Remember 8, we have a positive and negative. Going back to our review problem, our first review problem, we have to make sure if we can simplify this. 8 is 4 times 2, right?
Yes.
And then I can take the square root of the one that piece I can do, which is the 4. So I have positive and negative. The square root of 4 is 2, and then the square root of 2 we can't do. We come out evenly. So we just write square root of 2 to have an accurate answer. Okay? So that's why we reviewed that before, because we're going to be using that. All right? Questions on that? You guys okay with that? You want to try one on your own? Try one more to make sure you have it down? Yeah? Okay. So we've got one more. Alright. And by the way, guys, if you get something like 81 divided by 3, if you have a calculator and so on, you can pull it out and do the calculation and put your phone back away. That's fine. If you have a calculator you want to have, if you need time, that's fine too. Okay? Alright? I'd rather have you use the calculator and be accurate and not frustrate yourself than than do it quickly, because I'm more worried about the process, that you understand the process right now. Okay? So the calculator helps you be accurate. Alright, so most of you did a great job with this. You said I've got to get the x squared by themselves, so you added the x, and I really like the way I saw a couple of you referring back to what you had done before to help you out. And is that something you could do on a test? Could you get your notes out and use that to help you refer back to on a test? Okay, excellent. So we got 3x squared equals 81. And you divided both sides by 3. As you said, I got to get this x squared down to just 1x squared, just like it was just x. And you ended x squared. And a lot of you just wrote down 81 over 3, and then you went to simplify that. And that's fine. 81 over 3 is the answer. It's just not in the simplified form, is it? Okay? And most of you got that that would equal 27. And then you said, well, a lot of you knew you had to take the square root at this point for every amount of time. So you said the square x equals, and let's see how many of you remember to put this down. Okay, you didn't forget that positive negative piece there. Don't forget it. Put it in there. Okay, square root of 27. And then you have to remember that the square root of 27 is, now we have to simplify it like we did the first problem. So we have to find the factors. 9 times 3, right? And then I can square root that. It can help you finish it out. So square root of 9 is 3, and I can't do the square root of 3 and have it come out evenly, so I just write square root of 3. Okay? So those of you that didn't quite get there, now you see what to do. Good job. All right, so I'm going to have you do, we're going to go forward because I'm doing all these to help give you the tools to be able to do some of the lessons. So we got one more tool that you use to be able to do, kind of go through the lesson and be able to do the lesson. And so quickly, just what do you know about Pythagorean theorem? I was going to do this other thing, we don't have time to do the whole thing, so we can do the activity. What do you know about Pythagorean theorem? Okay.
I learned it after I about the main part of it.
Okay, so what do you remember about it? Do you know what it has to do with at all? It has to do with triangles. It actually specifically has to do with right triangles. Okay? What are right triangles?
A triangle has a 90-degree angle.
A triangle that has a 90-degree angle. Yeah. So when we're talking about the Pythagorean theorem, we're going to talk about a relationship that happens when we have right triangles. Okay? There's a special relationship that happens. So some of you may have to cut some of these out, but there's also some of the pieces, the squares at your table. And you're going to take those squares, and because of time, I'm going to help you. If we had more time, I'd let you play around a lot more with them, but because of time, I'm going to give you a couple hints as to what to do. But you're going to, if you need squares at your table, I've got some of those, and you're going to cut those out. And so if you have some, then partner with somebody. Okay. And you're going to take the squares, cut them out quickly, and you're going to try and find different combinations. And you're going to try and find different combinations of the three squares to make right triangles. See which ones make right triangles. Okay? So, for those people, all right. So, what that means is if I have the squares, I'm going to take the squares and I'm going to put the corners together, and then I'm going to take the other square and I'm going to put the corners together and make sure it's just the corners touching. And you look at that and decide, does that make a right triangle? Okay? And whatever you chose, you're going to, the paper that was just passed out, you're going to fill it out. Okay? And it says the length of the small side. So what's the length of this side, the side of one of these, this square right here? So 10 squared. So what's the length of the side? 10. Okay, what's the length of this side? That's 12 squared. 12, right? Okay? And so you're going to, when it says the length of the side, you'll put that number in there, and then it says the area of the square. So what would the area be of the 10 squared? 100. You don't have to count squares yourself, do you? Did it for you. Okay, and same with the 12 squared, and all of these. And then you decide that it says to fill in the area, small area plus the medium area, and then what does that equal when you add them together, and then compare that to the large area. And you also have to recognize, is it a right triangle or not? You say yes or no. Okay? So if you're going to look for the, when you find one that's a right triangle, what do you notice about what's happening? Now I'm going to give you a couple hints to start so you get the idea. I would say try 3, 4, and 5 to start with. So your length size, 8, 10. No, you can use more than one. Okay. You say 10, and then try 5, 12, and 13. So I'll write those up here. But try those really quickly because I want to make sure we can get Ms. Alvarado to get herself set up. Okay? So I wrote them right here. And okay. No. Where'd you get it from? Here? That's it. Okay. All right. So. All right. I think we do. Okay, so once you put it together, you see it's the right triangle, okay, and then do the next one quickly. We're going to have about a couple minutes. We're going to share out what we're finding.
So we're going to use like one here to be a triangle up to 8%. Right. The small area, the large, and there's
That's confusing. What's confusing? Math. Okay, so what did you find out? If I really get the corners just right, is it going to make a right triangle? Okay, it looks like it, and I can figure that, compare that to like the corners here and see if that's right. Okay, so if it makes a right triangle, let's go into the small button then. Small, three, the three there. Then move down that. Length of this one. Okay. Then what's the area of the small square? 3 squared equals 9. Okay. 4 squared equals 5. Then what do we say to do? Small area plus the medium area. So right step 2 things down. This is small area. Small area. Try some others. Try some others.
Oh, okay. That was Is that 150 or how much is it? Yeah. The last one. No, that's the 154 because we added. Oh, okay. Oh wait, no, correct. Yeah, you're welcome. Yeah. Alright, yeah, we did. Oh, yeah, you're the magician. Yes.
All right, we need to kind of wrap up here. So what did you guys find? What did we find by doing this?
No. Everything was on the side of the square, or a right triangle.
Okay, well, not every single time it would have been. Okay? Every single time it shouldn't have been, actually. Because not all of them make right triangles, but the ones that are right angles, right triangles, because they don't all have right angles. What, if you found one that made a right angle, what did you notice? I'm going to tell you right now, these made right angles. What did you, if you tried one of these, what did you notice that happened?
Well, I know the first time we did 3, 4, and 5, we ended up with the small, medium, and the large.
Oh, okay. So I'm going to wait for just a second. We've got to get this out before we go. This group found out that, like with the 3, 4, 5, the small and medium areas added up to be the same as the large area. Okay? And that actually is the right triangle. So those of you that found ones that didn't match up, those are not right triangles. Okay? So basically what we said, and you need to write this down because it's a lot of things. If you said the length of the smaller side of the square, which we call a leg on the triangle. So if you have the triangle, right triangle, this is the leg, and the long side across from the right angle is the hypotenuse. If I took the length of the side of the square, remember the squares are off of these like this, right? The leg squared, the length of the side of the squared, plus the other leg squared, gave me the longest side of the square, the biggest square, that side, squared also. Okay? So if I give you if I call this side, color. If I say this side is 6, this side is 8, this side is 10, I'm going to say the 6 squared plus the 8 squared, and that should give me the 10 squared. The length. Did anybody do the 6, 8, 10?
Yeah, we did.
You did? Did it come out the same? Did the area come out the same?
Yeah.
Yeah. So we've got, if I find the square, down the area of the square that has the side 6, the leg, the area square that has side 8, that gives me the 10 squared. Okay?
You said leg 2 plus leg 2?
Leg, no, the first leg plus squared plus the second leg squared.
Okay.
The shortest side squared gives me the length side squared. So quickly write your summaries for today. Make sure before you walk out, go ahead and grab the papers and toss them to the squares and stuff and toss them in the trash before as you walk out so I can floor. Make sure I get your namespace up here, right up here on this chair. Oh. Make sure you do your summaries. So maybe you have to ask you guys to turn these in. Make sure you're doing your summary. Make more point. And scissors are up here too, and there's about 3 pairs of scissors out there. Go into the main text. Okay. Look at their stain and their stain. Good.
hate that.
Okay.
Don't tell Mrs. Wise that, she's like right behind you.
Well, I know that not everybody likes
I love
math, and it's challenging, and it uses other parts of the